Hello everyone. In today's video, I'm actually gonna talk about a game I made recently using C and Raylib. I think I'll start by showing you my GitHub. Uh, so, yeah, it's pong-c-raylib. So I basically recreated the Atari Pong, but using the Raylib header in C. And in this video, I'm gonna explain the code behind it. I'm gonna explain how it works and why I did the things I did in the game and stuff like that. So it's two player. It's only two players. Not I didn't add a single player mode to this because that's just kind of hard. It has an undecorated game window because I'm running a Wayland window manager, and if it was decorated, then yeah, it was kind of buggy basically. You can use any C compiler you want. You control the player A with WNS and player B with up and down. Yeah, I think that's about it. Okay, I'm gonna go to the project directory. Yeah, so this is everything that's inside it. Now you'll notice I have a couple of shell scripts, and that was because when I was just using clang main.c dash o pong dot out, and then you do dash l raylib, right? It wasn't actually working when I did that, and I think that's a NixOS issue. If I had a raylib that .a or something, if I had some raylib files in this directory, then it would have worked that way, I'm assuming, but it didn't. So I at that point I was just concerned about it working, so I asked ChatGPT to make some scripts to help me do this. So for instance, there's this update flags script, so whenever I rebuild my NixOS, the directory of raylib changes obviously, so I run this. I actually updated this recently, so I'm just gonna run it just in case. Okay, build.sh, that's fairly simple. It's just building. I just didn't want to have to type this whole command, so I made it a script. Okay, so if I do build.sh, yeah, that's how it builds. I think you'll get the gist of it. Now I'll show main.c. Okay, so actually I think, yeah, I'll just show you all how the game actually works. So checks main.c. Okay, bruh. Okay, sorry. That's like pong.out. Yeah, so this is how the game works right now. I'm actually like playing single player right now, and it looks fairly similar, I think, to the original Pong game, with the exception that the half line is not dotted. Like in my version, the half line's straight, but in Atari Pong, yes, in Atari Pong the half line's dotted. 69. Anyhow, yeah, the half line is dotted, but in mine it's a straight line, and that's because if I was making it a dot, I just have to add a bunch of lines, and I just didn't think it was worth my time. But yeah, yeah, I'm gonna go through the code of this right now. So I'm just defining BG color black and white. Frankly speaking, I don't really need this to be a variable thing, but I'm doing it anyhow because you never know. Maybe you want it to be Grovebox black and Grovebox white or something. I don't know. It's for the user more so than me. Yeah. Over here I have some constant variables which are never gonna change. That it's why they're constant. So I have the width of, and the height of the window. My PC has an HD display, so and I didn't want it to take the whole space because then I can't see anything else. So that's why it's 1024 to 768. That's also the resolution of many old monitors and games, so it kind of fits the retro feel. So that's why I have this resolution. The paddle width is 14. These are just arbitrary numbers. I just thought it looked good. Yeah. Paddle movement, paddle. Okay, so these are some variables I'm gonna explain later on. Actually, paddle movement's fairly straightforward. So yeah, whenever you press these keys, uh, so for instance, if key down is W, then it's gonna move. Paddle A is gonna move up uh, by the value of paddle movement into dt. dt is get frame time. I sort of made it more physicsy, so I just called it dt. It just makes more sense for some things like velocity and stuff. Uh, yeah, like over here, ball x is, I don't know, it just makes more sense to me. The ones that aren't constant are obviously change. Float paddle ay. So that is the y coordinate of paddle A. At the start it's this, but they obviously change for paddle A and paddle B depending on how many times you like press your W, S, and up and down keys. Half line width, I made it 5 because it's visible. It's not too small, not too big. Some of these are arbitrary. Like you could change them. It doesn't really matter to the actual code. Now ball X and ball Y, these are more important. So ball X, that's the X coordinate of a ball, and ball Y is the Y coordinate of the ball. And ball X basically in Raylib, rather than the coordinates being the way you'd expect from, say, a math, like a graph, rather than X increasing this way and Y increasing this way, X still increases this way, but Y actually increases this way. I'll show you what I mean. So Y actually increases as you go down. X is the same, but yeah. Anyway, that's a computer thing. So that actually explains why over here, when I'm pressing W, I want the paddle to go up, but I'm subtracting paddle movement from paddle AY's Y coordinate, and this is why I'm doing it. That's just how it works in Raylib. I'm initting the window with this width, height, fairly straightforward. This is the while window should close. You just do this if you want a graphical window, I think. Like I was copying a YouTube tutorial for just making a simple Raylib C game, and this is what the guy had on it, so I included this line. I also had float dt. Originally it was I think it was named something else. I just changed it to dt because, you know. Okay, I'm gonna explain all of these. I already explained the key presses, and now I'm gonna explain these ones. So the thing is that it's far more complicated than it looks, because in this game, you see the ball is like actively bouncing around the window. Like if it bounces off the horizontal of the up and down borders of the window, it bounces. But if it touches these borders, nothing happens. In a sense, it doesn't bounce off them. It then teleports to the center. And all of these were intentional. I had to program them separately. 6, 7. Anyway, so the way these work is that firstly, if paddle AY I'm basically limiting the paddle y coordinates. So you cannot actually move the paddles out of the screen in either direction. Same for paddle B. It cannot leave the screen basically. That's why I'm doing this. Because if you leave the screen, then you can't really play anymore, right? So um and then if ball y is less than 0, yeah, so this is basically saying that if the ball is going here, then hang on, I'm just gonna make it bounce so that, yes, so it's bouncing off the top, right? The way I'm making it bounce, because obviously I don't have like a physics engine in this or any such thing. What I'm really doing is for up and down, it's the same both ways. If the ball's y coordinate is less than 0, or it's greater than the height of the window minus the ball size, if that happens, then I set the ball's y coordinate to 0, or the height of the window accordingly, and then I actually multiply the ball's velocity in the y direction with -1, so that it flips the direction. I think that's straightforward. Uh, so that's how the bouncing works on the y direction. The x direction is pretty similar, but obviously you're multiplying the ball's x velocity into -1. Uh, and it only bounces on the x direction if it hits the paddles. Now, when you look at this, you'd assume it's just one paddle. It's actually 3 paddles that you're moving. There's 3 paddles centered here, and this is because I wanted it to be that if you if the ball hits the center of the paddle, then it's just gonna go straight, like yeah, see, it's just gonna go straight if it's the center of the paddle. However, if it hits the bottom, it's gonna bounce downward, and if it hits the top, it's gonna bounce upward. You know, that's the way it kind of works on the original version of Pong. So that's why I made it like this. It also makes the game more fun, obviously, because you can change the y direction. Because otherwise, it's just gonna be a really boring game, right? Now, the way I did this was obviously making 3 rectangles, and I obviously, like, the x coordinates is the same, so is the width and all that. Height is height is paddle height divided by 3 for all of these. I had to do some extra stuff for the y coordinate because I didn't want them to overlap, obviously, so they can't have the same y coordinate. What they're really doing is for the top one on the top, you have paddle AY. Hang on, I'm just gonna, yeah, it just looks better to my eyes now. Okay, because it was too big, the line was getting cut off for paddle BY. Sorry, I got distracted. Okay, so for paddle A top, that's just using the paddle A y coordinate. It would be the same way if it was just paddle A, like without any separate sections. But for the middle one, it uses paddle A y plus a third of the paddle's height. If I can open Tux Paint. No, I don't have Tux Paint anymore. Fine, GIMP. Actually, I don't know how to use GIMP. I'm not sure I'll be able to show what I mean. Yeah. If I make like a template, A4 size, I don't know. Okay, actually, I think I'll probably be able to show what I mean on this. I'm just getting my mouse. Okay, so forgive me my bad drawing. This is generally the first time I'm opening GIMP, but the paddle is split into 3 sections, right? Now the top section only extends to a third, and to get the middle section, I am having the y coordinate, which is this, and then I'm adding a third of the paddle's height, which is obviously this, so that it's always going to be extended. Now paddle a bottom, the bottom section, that's basically the same thing, but I'm adding two of these obviously to paddle A's uh, y coordinate. And paddle B basically works the same way. The width is a bit different obviously, because rather than having it to be from like 0 plus 5, instead the width is gonna be the entire width of the screen, like the whole screen, and then you're subtracting 5 because I want a gap of 5, and then again you're subtracting paddle width, right? Because the coordinates, x and y coordinates, are always taken from the top left corner of whatever shape you have. Okay, so that's how the paddles work. Obviously the ball, it's fairly, all of the arguments are the variables I said at the beginning. Now the check collisions, I didn't actually know this. Like I first asked ChatGPT how to have like hitboxes, and luckily I didn't have to make one by myself. There's already a function for it. I can put it into an if statement where if there's a collision between the rectangles of ball and paddle A top, or over here I'm sort of simplifying. I don't really need to have all of this in one if statement, but I think it just keeps things more consistent, because basically what's happening here is that, because no matter what paddle you're on, the bottom, middle, top section, it's always gonna flip the x velocity of the ball. So I might as well have that all in one if statement. But that's an organization thing. You could do it in separate if statements. And then over here for paddle A top and paddle B top, for both of these it subtracts the ball velocity in the y direction with paddle bounce. Sorry, it doesn't subtract it, it equals it. I have made it in this game so that the y velocity can only be 3 values, which is 400 dt, minus 400 dt, and 0. And the reason I didn't want to make it anything else is because I don't know, I know in the original Pong game you can make it way higher and lower. Like it just sort of depends on how many times you hit it with the corner of the paddle. But in my version, I think it's just simpler to play and understand if there's only 3 y velocities that the ball can have. And even in this way, it's not like the game's very easy to play because of this, because you'll imagine, okay, maybe the opponent just sort of sticks you into like a straight loop. If like, the ball just bounces straight and forever, if you know what I mean. But that doesn't make it easier necessarily, because bruh, I can't make this straight loop for some reason. I'm talking while I'm doing this, and it's just hard to do that while I'm talking. Yeah, over here I'm just drawing the rectangles. Over here I'm adding the paddle points. You would have seen the point in the top left corner and the right corner, right? Also the half line. Anyway, the points are actually a bit more interesting because I set them up in a weird way. So I mean the y, I just like made it 15 because it's a bit spaced from the top. Font size is 100. I just like arbitrarily decided that. Now I struggled a bit with making these both of the points similarly spaced from the half line. Right now you can see that it's pretty similar, right? But that took some effort. Over here I had to, for the right side it was fairly simple. I just did 2 into width divided by 3, so that's basically 2/3 of the width. So the half line's here, right? and then you have the width, which is 1, and then you're multiplying that into 2/3, so the point is around here, right? But when I tried to make it a third for the left width, uh, it looked bad because obviously the text has a width and I'm not taking that into account. Now I then tried to make it like I tried to make a separate function where it would find the length of the text, but at that point it just I didn't like it much. So what I did instead is I just tried to find a random number. Like I would just keep subtracting it with random integers, and until it looked good, and then I just turned that integer into a fraction of width. That's how I got this. Yeah, that's that's it. That's basically how my game works. Originally I'd made a pie game. Mm, Squash. It's not Pong, it's Squash. It's like, sorry, Python Squash. No, it's main.py. Wait, what? Oh, I don't have pie game anymore? Weird. Really? Oh, it's Python 314 dot py game or something. Yeah, bruh. You know what? Let's quickly change the nixos configuration so that packages dot mix. Sorry. Yeah, I'll just add pygame in this. Okay. Yeah. In the meantime, I can show you the code for squash.py. I'm gonna have to go back to the directory. Okay, bruh. So, what this is doing is that it's actually fairly similar to the Pong game. I'd made this before, and how this works is its logic is for the ball and stuff is fairly similar, but instead of using just black and white squares for everything, I have images. You can see I'm uploading images from the assets folder, and these are some of these are transparent images. When I was making this in Windows, I had an icon, like I turned this into an exe. Oh yeah, I think I got pygame now, so I can run this to show you. The main problem is that in Neri, I'm pretty sure it's a Wayland, it's a Neri issue, but whenever I run this, it just looks really bad. Yeah, you can see first off, the frame rate's just cooked, and secondly, there's obviously this whole window problem, which looks really bad, and I don't know why. Yeah, it's really buggy. I don't know why it's like this. Uh, oh my, it's just unplayable. It's a Neri issue. It was working perfectly on Hyperland. Anyhow, I'm learning C anyways, so, and also Raylib syntax isn't that much more complicated than Pygame. In fact, I'd say that Raylib's so far it's far easier. The syntax of Raylib is far simpler than the syntax of C. Sorry, the syntax of Pygame. Because I mean, if I compare both of these, I mean, it's if, for instance, if I show you the keys, like they're pretty similar in terms of syntax, difficulty, I should say. Like the only hard part about Raylib is the C syntax, which really isn't that bad once you get used to it. So yeah, I'm actually really impressed with Raylib. I'm gonna use this thing more often. But yeah, that's how my Pong game works. thank you all for watching me ramble about my coding project. See ya.